Channel catfish is North America's most numerous catfish species. It is the official fish of Kansas, Missouri, Iowa, Nebraska, and Tennessee, and is informally referred to as a channel cat. In the United States, they are the most fished catfish species, with approximately 8 million anglers targeting them per year. The popularity of channel catfish for food has contributed to the rapid growth of aquaculture of this species in the United States. Distribution and habitat. Channel catfish native to the Arctic, being well distributed in lower Canada and the eastern and northern United States, as well as parts of northern Mexico. They have also been introduced into some waters of landlocked Europe and parts of Malaysia, and almost as many parts of Indonesia. They thrive in small and large rivers, reservoirs, natural lakes, and ponds. Channel cats are cavity nesters, meaning they lay their eggs in crevice, hollows, or debris, to protect them from swift currents. In Canada, the species is largely, though not exclusively, limited to the Great Lakes watershed from Lake Nipigon southward. Characteristics. Channel catfish possess very keen senses of smell and taste. At the pits of the nostrils are very sensitive odor-sensing organs with a very high concentration of olfactory receptors. In channel catfish, these organs are sensitive enough to detect several amino acids at about 1 part per 100 million in water. In addition, the channel catfish has taste buds distributed over the surface of its entire body. These buds are especially concentrated on the fish's 4 pair of barbels surrounding the mouth, about 25 buds per square millimeter. This combination of exceptional senses of taste and smell allows the channel catfish to find food in dark, stained, or muddy water with relative ease. Channel catfish also possess a web-hearing apparatus which amplifies sound waves that would otherwise not be perceivable. Behavior. Feeding. Catfish have enhanced capabilities of taste perception, hence called the swimming tongue, due to the presence of taste buds all over the external body surface and inside the oropharyngeal cavity. Specifically, they have high sensitivity to amino acids, which explains the unique communication methods as follows. The catfish has a facial taste system that is extremely responsive to L-alanine and L-arginine. More specifically, the facial taste system senses heightened levels of L-amino acids in fresh water. Feeding behavior to food is due to amino acids released by food. It is reported that this causes maxillary and mandibular barbell movements which orient the catfish's posture and food search. When the food stimulates the taste receptors, it causes more excitation, which see as exaggerated biting, turning, or mastication. Communication. The channel catfish is adapted to limited light conditions. Members of the genus It, which inhabit muddy waters, do not depend solely on visual cues. Instead, they are known to rely heavily on chemotaxic cues. Sound production may be another important means of communication among channel catfish and other species living in turbid habitats. Chemical communication. The North American channel catfish is an Ostariophysan, or a bony fish occupying a freshwater habitat. These fishes are known to produce club cells and alarm substances for communication purposes. Both the fish's habitat and the presence of chemosensory cells covering the body are presumably the results of favored selection for this method of communication. Catfishes are capable of producing and recognizing individual-specific pheromones. Through these pheromones, a catfish can identify not only the species and sex of a conspecific, but also its age, size, reproductive state, or hierarchical social status. Territoriality in channel catfish is identifiable by a change in body odor, which is recognizable by other members of the same species. species. This chemical change in the amino acid composition of the skin mucus can be noted by chromatographic methods, and are not long-lasting, rather, they last only long enough to communicate to other fish in the vicinity. Changes may be the result of the release of the contents of the club cells. These cells do not open directly to the surface of the skin, but injury caused by fighting and other agonistic behaviors may release the cell's contents. Since catfish have a dominance hierarchy system, information relative to the change of status of any fish is important in recognition of the social strata. Distinction between a communication signal and an information signal. In the channel catfish, while a communication signal is directed toward the receiver and contains a specific message, an information signal is a part of the general existence of the individual of the group. For example, release of an alarm signal will communicate danger, but the individual's recognition odor is only an information signal identifying one fish from another. With regards to the function and contents of the club cells, it is reasonable to suggest that the club cells serve different functions throughout the fish's life cycle. Variation in the contents of the club cell's information signals therefore may change with the species' needs at different stages of life. Sound production. All species of catfishes can generate sound through stridulation, and many produce sound through drumming. Stridulation consists of the clicking or grinding of bony parts on the fish's pectoral fins and pectoral girdle, and drumming consists of the contraction of specialized sonic muscles with subsequent reverberation through the swim bladder. Variability in the sound signals created by the channel catfish depends on the mechanism by which the sound is produced, the function of the resultant sound, and physical factors such as sex, age, and temperature. This variation may result in increased complexity of the outgoing signal and may allow for increased usefulness of the signal in interspecies communication. In the channel catfish, sounds are produced only by pectoral stridulation, as this species does not express sonic missiles. However, the swim bladder may still be used to help with audition. Due to the high density of water, sound travels 4.8 times faster and over longer distances underwater than in air. Consequently, sound production via stridulation is an excellent means of underwater communication for channel catfish. The pectoral spine of the channel catfish is an enlarged fin ray with a slightly modified base that forms a complex articulation with several bones of the pectoral girdle. Unlike the other pectoral fin rays, the individual fin segments of the spine are hypertrophied and fused, except for at the distal tip. The surface of the spine is often ornamented with a serrated edge and venomous tissues, designed to deter predators. Sounds produced during fin abduction result from the movement of the base of the pectoral spine across the pectoral girdle channel. Each sweep of sound consists of a number of discrete pulses created by the ridges lining the base of the pectoral spine as they pass over the rough surface of the girdle's channel. The stridulation sounds are extremely variable due to the range and flexibility of motion in fin use. Different sounds may be used for different functions in communication, such as in behavior towards predators and in asserting dominance. In many channel catfish, individuals favor one fin or another for stridulatory sound production. The first ray of the channel catfish pectoral fin is a bilaterally symmetrical spinous structure that is minimally important for movement. However, it can be locked as a defensive adaptation or used as a means for sound production. According to one scholar, most fish tend to produce sound with the right fin, although sound production with the left fin has also been observed. Hearing, the inferior division of the inner ear, most prominently the utricle, is considered the primary area of hearing in most fishes. The hearing ability of the channel catfish is enhanced by the presence of the swim bladder. It is the main structure that reverberates the echo from other individuals' sounds, as well as from sonar devices. The volume of the swim bladder changes if fish move vertically, and thus is also considered to be the site of pressure sensitivity. The latency of swim bladder adaptation after a change in pressure affects hearing and other possible swim bladder functions, presumably making audition more difficult. Nevertheless, the presence of the swim bladder and a relatively complex auditory apparatus allows the channel catfish to discern different sounds and tell from which directions sounds have come. Communication to predators. Pectoral stridulation has been considered to be the main means of agonistic communication towards predators in channel catfish. Sudden, relatively loud sounds are used to startle predators in a manner analogous to the well-documented visual flash display of various lepidopterans. In most catfish, a drumming sound can be produced for this use, and the incidences of the drumming sounds can reach up to 300 to 400 per second. However, the channel catfish must resort instead to stridulation sounds and pectoral spine display for predator avoidance. In addition to communication towards predators, stridulation can be seen as a possible alarm signal to other catfish, in the sense of warning nearby individuals that a predator is near. Fishing. Channel catfish are omnivores, and can be caught using a variety of natural and prepared baits, including crickets, night crawlers, minnows, shad, freshwater drum, crawfish, frogs, dewheads, sunfish, and suckers. Catfish have even been known to take ivory soap as bait and even raw steak. Jug lines, trot lines, limb lines, and bank lines are popular methods of fishing for channel catfish in addition to traditional rod and reel fishing. Another method uses traps, either slat traps, long wooden traps with an angled entrance, and wire hoop traps. Typical bait for these traps include rotten cheese and dog food. Catches of as many as 100 fish a day are common in catfish traps. An unusual method practiced in the southeastern United States is noodling, catching catfish by hand. When removing the hook from a catfish, anglers should be mindful of the sharp spines on the pectoral and dorsal fins.